Hey everybody, this is Larry. This is day 27 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today's problem is evaluate division. Okay, so you're given equations A over B is equal to K. Okay. No division by zero, no contradiction. Okay, so A over B is 2. B over C is 3. Okay. Number of equations is 20, and the number of equations dot length is 2. Okay, so this turns out to be a graph problem, and because of these guarantees that there's no division by 0 and the bigger one is contradiction, we can actually figure out as a graph problem. And the way that I would do that is from A to B, there's an edge where A over B is 2, right? And so forth. And then you just have to figure it out in a way. I think that's roughly right. And the algorithm that I would use for this one, because n is at most 20, is just Floyd-Warshall. Because then we can answer queries very quickly. That's one of the benefits of Floyd-Warshall in general. So that's not actually n per se. N is the number of unique things. So yeah. So let's do. Yeah. Okay. Let's have the names. A dictionary, and then for x, y in equations. And now we just want to, count the number of things. So yeah. If x in names or not in names, name sub x is equal to index over 1. If y not in names, so basically we just this is right. Index and x. So basically we just mapping names to a number. So but that's pretty much it. Name. So basically we're converting these inputs into an index. By having this in the lookup table. Mapping variables to indexes. And then now we can go through the equation again. And then now we have an n. N is equal to the length of the names. And now we can create a graph pretty much. So of let's see, what do we want to call it? So basically right now I'm just trying to figure out what is a good standard value, because basically we just want this times n for this and n, and because there are 20 equations at most there are 40 variables, so maybe I'll just call it none, maybe, I don't know, let's see. And then now we do the classic Floyd-Warshall, and definitely look it up if you're not familiar with it. It's kind of a dynamic programming problem, but yeah, I don't want to get into it because it's probably out of the scope of this. But yeah, hopefully that makes sense. And basically we try to get to the closure of this graph, and now we have the all pairs shortest graph, and I think this should be okay, because if there's no contradiction, then this should always be okay. Maybe that, we'll see. If it's not, then that's fine. Well, I missed something, which is that I need to go through this equations again to parse it. So we want to say names of x, names of y. Basically now we have these indexes, right? And also I'm missing something on the values, so I actually needed to do that. Because then now we get the values of index, right? And then now for Q inquiries, or was it A and B? Okay, for XY inquiries, we just No, let's have the results. Sorry, I'm not explaining that well because I'm just coding it up. I'll go over the code in a short while. Yeah, if g sub x of y is not none, results dot append g of xy. Otherwise, I think it's -1, right? Okay, so that's not great. Because there should be... This should never happen unless I'm missing something. Oh, maybe the names of y, x and names of y thing as well. Oh, I just have typo here. Whoops. Oh, no, still. This indexes must be in... Oh, yeah, I forgot to map this. Which is, we have to map it back to the names. Because these are strings. Okay, a lot of silly typos, but that's okay, maybe. And let's also put in the other test cases while we wait. Oh no. Key E is not in. That's odd. Okay, let's take a look real quick. Again, I wish that this has a button for me to import all the other test cases, and I'm doing this live, so apologies for that. Oh, this G may not be in the index. Okay, that's fair. So basically queries may include things that are not in equations. Okay, that's reasonable. So basically, if X not in names or X not in, Y not in names, so we just have to, add more, add more things. Okay, so that's not great that we all, I mean, it's not the worst thing, but it's not the best thing either. So how do we get 0.5? B over A. Oh, so okay. So the inverse, we have to do the inverse as well. So that makes sense. I just didn't think about it that much, to be honest. But that means that we just have to, populate the inverse as well. I don't think this is that tricky, hopefully. Knock on wood. Because every time I say that, I get in trouble. Yeah, so now everything looks okay. And the thing is that we would probably add more checks to make sure that it's consistent. Because a lot of problems will not give you that guarantee. But because they do give you the guarantee here, we don't have to check for it. And the division by 0, for example. Everything looks okay. I think I'm going to submit just because I'm a little bit lazy on stream. I would definitely add more test cases, especially stuff around with like no edges and stuff like that. But yeah, okay, so this is accepted, so that's great. So what is the complexity of this, right? So we know that equations will have at most 40 different names. So that means that it's going to be, that's our n. So that's going to be n cubed because that is the complexity for it, for sure. And for each query, we do all of one work. So it is going to be all of n cubed plus q. I think I said cube and q. So yeah, so running time is going to be n cubed plus 3. Or plus q. Man. And the space is O of n cubed. Also plus q because you need one for each answer, right? So that's the time and space complexity. So the idea for us, and I did hand wave a little bit because, again, we don't have to worry about the 0 and no contradiction. So that means that it's in a way, you try to figure out the transitive closure. It's not quite that because it's not the Boolean, but basically if you're given A divided by B and B divided by C, you want to map A over C, right? So that's basically what the forward ratio does for us in a way. So it is like the transitive calculation of the problem, and then we pre-calculate it for every possible pairs, and because n is equal to 40 at most, this is pretty fast, right? And we do some O of 1 lookups here, and that's pretty simple. But But yeah, but otherwise, this is just mapping it to a graph problem. So first we map each name in the equation into an index, which is a number, which makes it slightly easier for us, though you don't need to do that if you're clever. And then we pre-populate the values that we know to be true, which is, the values and the inverse of the value. And then we just do this for Warshaw. And then at the very end, we just respond each query by looking up in this table that we created from Floyd Warshaw. Cool. That's all I have for this problem. Let me take a look at the hint. Oh, yeah, okay, fine. That's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button. Join me on Discord. And I will see you on the next problem tomorrow. Bye-bye.